You know that feeling, right? You spend hours tweaking your resume, you finally hit submit, and then nothing. You just kind of wonder, is a real human actually going to look at this, or did a machine just toss it right into the digital trash? Well, today, we're not just guessing anymore. We are actually going to pop the hood on a real, fully functional AI resume screener. And honestly, the craziest part, we're going to explore this hidden, underground marketplace where these exact kinds of systems are bought and sold every single day as packaged solutions. It's this wild mix of machine learning, modern hiring practices, and, of all things, the academic gig economy. Let's get into it. Okay, let's dive right into this. We've all heard the advice, right? Make sure you optimize your resume with the right keywords to get past the bots. It's literally the most universal frustration of modern job hunting. We kind of treat these bots like these mystical gatekeepers that we have to appease with magic words. But the reality? It's way more grounded in pure data science. What's actually scanning your document is so much more structured and, frankly, a lot easier to understand than the rumors make it out to be. If we can understand the tech, we can understand the whole system. So here's how we're going to break this all down today. First, the resume black hole. Second, inside the AI screener. Third, how the tech works. Fourth, the real-world application. And finally, number 5, the student project ecosystem. Let's hit it. Section 1, the resume black hole. To really get why these AI bots exist in the first place, we gotta look at the sheer logistical nightmare HR teams are dealing with right now. So 400 resumes, one inbox. This is the massive, universal pain point driving all of this tech. When a company posts just a single job opening, it's totally normal for 400 resumes to flood their inbox almost instantly. Just think about that for a second. If a recruiter took, I don't know, maybe 2 minutes to read each one, that's over 13 hours of nonstop reading for just one role. Human filtering at that scale? It's basically impossible. So this isn't really a story about robots stealing jobs. It's just the reality that something has to do that first pass just to make the mountain of paper manageable. All right, section 2, inside the AI screener. So how do they solve that massive volume problem? Let's take a look. Today, we're looking at a specific AI resume screening system actively sold online by a platform called Kodatch. And the workflow for the recruiter using it is super clean. Step 1, you just drop in a PDF or a Word doc. No manual copy-pasting required. It uses tools like PDF Plumber and Python docs to just rip the raw text right out of the file for you. Step 2, the system instantly guesses the job category, like data science or web design. But Step 3 is where the real magic happens. You paste in the actual job description you're hiring for, and boom, it spits out a match score. It answers the literal only question the recruiter actually cares about: does this specific person fit this specific job? And what's crazy about this system is that it's not some sci-fi tech running on a giant Silicon Valley server farm. It is built on super accessible everyday technologies. We're talking a Python and Flask backend for the web interface, scikit-learn doing the heavy machine learning lifting, and the Natural Language Toolkit, or NLTK, crunching the text. And honestly, the most impressive part? The whole shebang runs on a completely normal laptop. No expensive GPU required, 0 monthly cloud computing bills. You could literally set this up and have it running locally in about 15 minutes. It's wild. Moving on to section 3, how the tech works. Now, what's really interesting here is when we pull back the curtain on all those tech buzzwords and look at the actual algorithms at play. Because under the hood, I promise you, there is absolutely no magic. It is just math. The absolute core of this thing is something called a TfidfVectorizer. Look, in simple terms, algorithms can't read English. They do not care about the bullet points describing your stellar leadership skills. They only understand numbers. So the TfidfVectorizer is just a process that takes all those human words in your resume, figures out how frequently and uniquely they show up compared to a massive data set, and transforms your text into numerical data. Once your resume is basically just a giant matrix of numbers, then the machine learning model can actually do its job. And once your resume is vectorized into numbers, an algorithm has to classify it. In the machine learning world, different algorithms basically compete to get the best results. For this specific project, the developers actually tested 3 different approaches: a LinearSVC model, k-nearest neighbors, or KNN, and Random Forest. And when they ran them against a held-out test split of the data just to keep things completely fair, the LinearSVC model came out on top. It totally defeated both KNN and Random Forest at accurately sorting the resumes. So what does winning actually look like here? It looks like an 85% accuracy rate. This model was trained on the Kaggle Resume Dataset, and hitting an 85% success rate on classifying these documents, that proves this lightweight student-grade bot actually packs a massive punch. It is a highly capable sorting machine. But remember step 3 from earlier? Just tagging a resume as data science isn't really enough. The system goes a step further by comparing your resume to a very specific job description and handing down a verdict: strong match, partial match, or weak match. And what's absolutely crucial to grasp here is that these verdicts aren't based on some totally made-up, arbitrary 0 to 100 scale that just looks pretty on a screen. No, these thresholds are carefully tuned to the real statistical distributions generated by the model. It's grounded in actual math, ruthlessly separating the real candidates from the ones who are completely unqualified. Okay, section 4, the real-world application. We've got this tight, efficient Python project running on a laptop. But let's zoom out for a second and connect this back to that massive global recruitment industry we started out talking about. Because this brilliantly illustrates exactly what's happening inside massive enterprise HR departments right now. The local code we just broke down, at its core, that is the exact same logic powering the screening layer inside modern applicant tracking systems, or ATS. When big companies are throwing huge money at HR software to handle those 400 resumes, they are buying a tool that does exactly this. It sorts by role, vectorizes the text, and flags the matches so a human recruiter only has to look at a short list of like 10 or 20 people. If you really want to know how to beat the ATS, understanding this one simple Python project gives you a literal inside look at how that very first pass actually works. Which brings us to section 5, the student project ecosystem. Because here is where the story takes a super fascinating turn. This specific codebase, it isn't actually being marketed to HR professionals at all. Let's shift gears and look at who is actually buying this code from Code.j and why. The target buyer for this AI screener is not a recruiter. It's a final year computer science student, specifically students getting their BCA, MCA, or BTech degrees. Put yourself in their shoes for a second. Final semester deadlines are right around the corner. The pressure is totally overwhelming, and they desperately need a working AI or machine learning project for their Viva exam, their final oral presentation. They can't just show up with a basic to-do list app. They need something that hits that AI sweet spot examiners absolutely love, something that looks amazing in a live demo, and most importantly, has super clean code they can explain line by line to a professor. This marketplace is incredibly pragmatic. It is literally a lifesaver for students who just don't have the time to train complex models from scratch. And because we're dealing with students facing down strict academic bureaucracy, an entire transactional business model has sprung up around this. We are basically looking at a project-as-a-service economy in full swing. The base code itself might only be 499 rupees, but look at these add-on services. They cater perfectly to academic submission standards. For 999 rupees, they'll hop on a remote session and set the code up on your PC so you don't fail because of a random installation error. Need a formal custom research paper? That's 1,000 rupees. A custom college-formatted project report? 1,500. Even the final PowerPoint presentation is templated out and sold for 800 rupees. It's essentially an end-to-end academic survival kit, packaged and priced for a very specific type of panic. And right behind all these transactions are real people finding actual, tangible relief. Take this quote from a client named Payal Tiwari, who bought a different AI project from the same platform. She wrote, "I wanted a website for my startup, and Code.j provided me the website exactly as I needed. I felt very good working with you." Whether it's to launch a startup or just to pass a brutal final exam, this marketplace is providing ready-made functional tech that solves immediate, incredibly stressful problems. It's this amazing, weird intersection of education, commerce, and code. Which brings us to our final thought for this explainer. We started out today trying to demystify the HR bots screening our job applications, and we ended up uncovering this whole separate economy of students buying the code to build them. So I want to leave you with this question. Does knowing exactly how the math, the TfidfVectorizers, and the LinearSVC models work actually make you a better job applicant? Or does it just make you a better programmer? Honestly, maybe by understanding the limits and the literal lack of magic in these systems, it can finally be both. Thanks for hanging out and diving into the AI resume screeners with me today. Keep questioning how the systems around you work, and I'll catch you in the next explainer.